And any discussion starting with OpenStack usually starts with the history, the timeline. OpenStack has been around for 11 years, going on 20 some odd releases now. So way back in 2010 on the left of the slide, we started with the Austin release. And that was basically a collaboration between Rackspace and NASA at the time. And you've got notes in your PDF that explain all of that. But you can see the releases are alphabetical: Austin, Bexar, Cactus, Diablo, with Victoria being the latest release. Typically, you'll see a release every 6 months. That does change from time to time, but 2 releases a year. Use that as a guideline. So Victoria came out in October. Wallaby is the next release, which will come out next month. And you've got a URL also on the slide for all of the information. So you can drill down for a given release and look at each of the components within a release. And I'll add, I talk components when I talk about the various pieces of OpenStack. You may have heard those called services or projects. I think OpenStack uses the term projects. I use the term components. Okay, real quick, Victoria again is the current release. That means you're going to get all the fixes for everything. The maintained releases, usually it is a 2-year window. So 2-year window means 4 releases, and it's a rolling window. So for example, when Wallaby is available, Victoria will be maintained, and Rocky will move to the end of life phase. So that's how you read that slide, and I'm not going to spend going through every single release there, but pretty much latest release, you get all fixes to all defects. The maintained releases, you will typically get major defects fixed. So if there's a major problem or if there is a security exposure. End of life, pretty much you can read into that. Surprisingly, there are customers running, say, Queens for their production OpenStack. It's end of life, but it's stable and it gives them the level of code that they want or the level of functionality that they need. So real quick, what is OpenStack? And this comes directly from the URL at the bottom from the OpenStack website. You'll hear the term cloud operating system. You might also hear the term Linux for the data center, depending on where you look for your definition. I found this one to be a good high-level one. So cloud operating system controls large pools of compute, storage, and networking resources. So I virtualize my machines, my instances, my storage, and my networking. Provides common authentication, and we'll talk about that in a second when we start going through the components at a high level. Authentication is the identity service, the keystone component. And we'll introduce those again in a couple of minutes. You have a dashboard user interface or dashboard UI, a browser-based UI that primarily gives you administrator control, allows users to provision instances or their storage, their networks, etc. Okay. I look at it as more of an admin UI, and that's my personal commentary, mainly because to me, a user UI is fairly quick and simple. So if I want to deploy an instance, I've got a couple of choices. With the dashboard, I've got a series of tabs, and as a user, I might choose, for example, maybe an instance that's too large, and I don't need as much storage or disk. And we'll talk about how you can control that, and typical story there, but we'll get there. Core components provide infrastructure as a service, and we'll talk about what those core components are in a second. IaaS, you have additional components for orchestration. I usually liken that to automation, fault management, service management, deploying containers, rating and billing, and monitoring and scaling. And we're going to touch on, and real high level, we'll touch on those components. So a few additional comments to supplement that definition. We're talking about open source code. So you've got an army of developers working in various companies worldwide to develop the code. Each project, each component has what they call a project team lead, and they go through design phases, and all the typical checks and balances are in place. But it's open source code. That also means it's not really a product. I get my OpenStack as a vendor distribution. So I get my OpenStack from a vendor, and that vendor may have value add code that they added on top of the base OpenStack. Examples there, you've got the Red Hat OpenStack, you've got Mirantis Cloud Platform that gives you an OpenStack distribution, Mirantis OpenStack for Kubernetes, which gives you an OpenStack distribution. And there are various vendors that will do that. And you can go out to the OpenStack marketplace and find a vendor. So the key thing there is each vendor uses the same source, the open source code, and then provides additional function or value add capability on top of that. OpenStack, the foundation, runs a survey every year of their user community, and the OpenStack itself is used for public, private, and hybrid clouds, with about 3/4 of the customer base using it for a private cloud. So just a little bit more other than the previous slide, a little bit more information. So accessing or consuming the OpenStack APIs. I mentioned the dashboard, browser-based UI. You can access all the functions. The component name or the project name is Horizon. That allows you to launch instances. I can deploy my containers, my Kubernetes clusters, for example. They all have the same look and feel because they're based on that same UI. And that's one of the advantages of plugging into the UI with all of the functions. I've also got a command line client, the OpenStack command. Basically, if I want to create an instance, OpenStack server create with additional parameters. Or if I want to list the images, OpenStack image list. The command is OpenStack. I also have REST APIs. So I can invoke the same functions through REST APIs. And then I also have available to me a Python SDK, software developer kit. The items you see in the next couple of slides that are highlighted in yellow are topics we cover in the Mirantis classes or courses. Okay, so as I go through this, you'll see a lot of those components are covered, such as this slide. This is the core components or projects. Keystone provides identity services. What do we mean by that? Well, authentication. So when you log in, and you'll see me log in during the demo, I have to specify a domain, a user, and a password, credentials. Once I get authenticated internally, Keystone gives me a token, and then that token is used for my requests. We talk about all those details in the classes. Okay, not enough time to talk about it here, but I'll mention it. If you're running other LDAP backends, lightweight directory access protocol, that will work with Keystone. So Keystone can hook into your LDAP backends to do the authentication. Without that, it just uses a database. The most popular LDAP backend is the Microsoft Active Directory. So I can hook in when I log in, I can have a single sign-on for all my apps and have that controlled by my LDAP backend, and then Keystone will hook into that. Images. Glance is the image service. What is an image? It's at minimum the OS for your instances. So I need an image to deploy an instance. At minimum, it might be my CentOS or my Red Hat or my Windows Server operating system. However, I do have the option. I can also bake or install software. So for example, the image might be used for a database server. Then I have the option of installing the database software in that image. And then when I deploy my instance, the database will be running on that instance. Networking is provided by the Neutron component. Some folks call it software-defined networking. Some folks call it virtualized networking. You can call it what you want. But basically, Neutron will virtualize your layer 2 and layer 3 networks, for example. It does more than that, but that's as far as our classes, that's about what we get into, layer 2, layer 3. Comes with what they call reference implementations, default implementations. So for example, the default layer 2 implementation uses Open vSwitch or OVS. If you don't like that, or you've got a different implementation, chances are that vendor that provided that implementation has an implementation or a driver in OpenStack. So you can go to your vendor and get your favorite networking vendor and get a driver to run on OpenStack. The compute service named Nova, that's all everything around instance creation and management. So Nova is the component that interacts with your hypervisor. Nova also interacts with the placement service. The placement service has usage data for each of the hypervisors, how much memory, how much CPU, how much disk. So when you deploy an instance, part of the Nova processing is to choose a hypervisor with enough capacity. So if you had a hypervisor that did not have enough memory, Nova wouldn't choose that. It would move on to another. It gets that data from the placement service. Swift, think about Swift. It's called the object store, but think about it as cloud storage. I can run Swift independently of the other components. What can I store in Swift? A good example are images, basically unstructured data. And then it has all of the properties built in to be highly available and distributed and etc. Okay. Another object I might store in Swift, videos, or put it in context of a company. Maybe I'm running a streaming service. All those videos for my streaming could be stored in Swift. Okay. Cinder is block storage service. Volumes. So block storage and volumes are synonymous. And again, I have any number of vendor drivers I can plug in for the back end. So if I'm partial to NetApp or Hitachi or Dell, I can plug their drivers in. It does come with a reference implementation, logical volume manager. That comes with your Linux. So that's the default block storage service. And we'll see during the demo creating a volume, for example. Load balancing, that's the Octavia component. Load balancing call it version 1, was part of Neutron. Over time, that has now been split and is finally completely split from Neutron into the Octavia component. But it provides your typical load balancing, and we'll see a scenario of that coming up. Heat is the orchestration service. If any of you are running Terraforms, okay, Heat is very similar. Except with Heat, I can automate anything OpenStack. So it's more than instances. I can deploy applications. And we'll see an example of that coming up. I can deploy my edge machines with an image set up for networking. So I can automate all that with Heat. I could even go so far as having a Heat template describe a company that I just acquired and create all the users and images and networks and everything that particular company needs in my cloud. Okay, so I can automate the onboarding process and make it a lot easier. If you're wondering, yes, Heat also integrates with the config management tools, your Ceph, your Puppet, your Ansible, your Salt, etc. Okay, so you need both. And Heat allows you to do that. So Heat can deploy your instances, and then you can invoke Ansible to go ahead and configure them, or Ceph or Puppet. Continuing on, telemetry. This is a group of projects or components. Ceilometer, AOD or AODH, and Yoki. Gives you auto scaling, for example. And that's important. Ceilometer will capture the metrics. What might be a metric? CPU utilization. AODH can then generate events based on that metric. So I can set up an event to say if CPU is greater than 80%, maybe I'm auto-scaling my web servers. So if the CPU is greater than 80%, then I want to add another instance, invoke the scale up policy. Very easy to do, especially when you do it from a Heat template. Okay. I can define all of that in a Heat template. And in fact, if you come to one of my classes, we'll discuss that. That's why it's highlighted in yellow. And you can copy that sample template. Gnocchi is the database. It's a well-performing time series database. You cannot use traditional databases like Mariah or Mongo for your telemetry. Your performance is not as good. So Gnocchi is the component for that. And Gnocchi is not part of OpenStack. It used to be, but it's still affiliated with OpenStack. Other components that customers are interested in, and a lot more customers are getting interested in. Magnum. You need or you want to deploy your container orchestration engines, clusters, Kubernetes, Docker Swarm, Apache Mesos. So Magnum will build a Heat template to deploy, and as part of that deployment, you say, for example, with Kubernetes, I want 2 master nodes and 5 worker nodes. Then that will deploy your Kubernetes cluster with the 2 masters and the 5 workers. Beyond that, if you wanted to deploy a pod, for example, you'd have to use the kubectl command. However, if you also install the Zune component, the container service, now you have an API for launching and managing your containers and your pods. You can do it from the command line. You can do it from the UI. So those 2 components together give you the deployment of your clusters plus an API to launch and manage the containers and pods. Okay, can't really do one without the other, but you can. And run each without the other. But if you're in the game, the containers and pods, if you're in that game, you want both. Next, ironic, bare metal, another project or component that is gaining in popularity. Instead of deploying VMs, you deploy bare metal servers. This is especially popular with the customers that are deploying their container orchestration engines, your COEs. So this also comes into play with Magnum, for example. I can deploy bare metal servers and then deploy my Kubernetes or Swarm or Apache on top of that. Okay, most shops are doing it one of two ways. Either they are deploying their clusters, and I'll call the COEs the clusters, onto VMs or bare metal. It's one or the other for that environment. So as a result, Ironic is getting increasing in popularity. Other components beyond those, there is a rating service called CloudKitty. Real simple, easy to use solution. Think about the user I mentioned earlier that said, well, I don't know how much disk space I need. I'm not going to pick the top most, the largest instance. I'm going to pick maybe one or two levels below that. So I may wind up deploying an instance with 100 gigabytes of storage. I may only need 20. I'm wasting storage. Guess what? Implement CloudKitty, send that group a bill, even if it's an internal organization. Okay? You have to justify, most of us have to justify our existence. So I could be an internal organization providing the private cloud services for my company. I can use CloudKitty to then send that department a bill, and that user that's wasting the disk space, they're going to get either an email or a visit from their boss. Now, generally, you wouldn't implement that, the billing right away, but you might give them a month or two and say, hey, this would be your bill. However you want to approach that. The other thing that's good for is a lot of folks tend to create instances and then forget that they created them and not stop them, not destroy them. So yeah, when that bill comes in and it's been a month or 2 months since they've used the instance, they'll start keeping track of that. And there are other solutions for that, other non-OpenStack solutions, but CloudKitty is the one from OpenStack. Another component, Mistral. It's a workflow service. Think of deploying an instance. Just keep it simple, one instance. And really, things aren't that simple, but let's just keep it simple. You might want, and think about deploying an instance, as complex a process as it is. That's just one step in the workflow. So you may want to add in a step before that for an approval. So for example, if they request more than 64 gig of memory, that has to be approved. So you get an administrator involved, and you can write that approval workflow or task before you allow the instance to be deployed. Then after the instance is deployed, what do you need when you get that instance? You need its IP address, and you need to know how to log in, your user credentials. I can put that information in an email and send it back to the person who kicked off the process. Here's your IP address, here's the user, and here's the user password, and automate that process. So Mistral, it's just an open workflow process. You define the steps of that workflow and what you want to have happen. It's done through YAML files. Additionally, there is a reservation service, the Blazor component. So if I know I've got a test next month, I can inject a reservation into the system so that next month, when the time comes, I should have my resources available. Masakari provides HA for your instances. Currently, only those running on KVM, though. So if an instance fails, it can be recovered. And you define that through policy in Masakari. Manaska provides monitoring. So it's the monitoring as a service. And in some cases, you'll see Manaska replace Solometer and AODH for your auto scaling. So that also comes into play in your auto scaling. And like I said, there's many, 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 many more. OpenStack is too big. I could probably spend an hour just going through slides like this. Okay, so you've got a URL there. And it's not one that's highly publicized, but it's one I usually check every release. And on that URL is links to all of the projects or the OpenStack components. So if you're interested in, for example, Manaska, you can go to that web page, click on Manaska, and then you'll get more details on it or any of the components. Okay, real quick. We've got a pretty busy slide here, okay? And I'll try to approach this step by step. This is something, by the way, you see in green, I would highly recommend doing with Heat. Define a Heat template to deploy my application, everything you see here. I could do it all manually, but we all know manual tasks, you're going to make errors. You're going to pick the wrong image. You're going to type something in wrong. Okay, so if you automate it, that's the benefits of automation. Everything's consistent every time. So I've got an application here, and I've got 4 web servers in the middle of the group. So we're going to have web servers front-ended by a load balancer on the left, and that load balancer will route my web traffic, port 80. Okay, so I set all that up. The load balancer alone is a series of 5 different commands from the command line. So automate all this. Use Heat. Got my web server, my app server where my app code is running. I may have that running on 3 different servers, database servers, other servers. So I'm deploying an application, not just an instance, an entire application where I can also add in auto scaling so that if my web servers get overloaded, I can add another web server and do it automatically. So I set that up in my Heat template. I launch my Heat template. That's going to launch my application. So every time my application is going to have the same look and feel, same application code, same web server, etc. Okay. Other little details on the slide. The load balancer is going to give you a virtual IP. So when we deploy, you'll see that in the demo, we're in the 10 dot network. My virtual IP is in my 10 dot network. I can't get to that from outside. I've got to have what's called a floating IP address, the FIP. If you know AWS, an elastic IP, same concept. But I would then have a public facing address. You'll see in our demo a 172 address where I would connect to a URL that has that 172 address. That's going to get routed through my load balancer to one of my web servers with the app servers and the database servers, etc., in the back end. Okay, so to do that, I need to define a floating IP. We'll see what that is in the demo. I need a security group rule for port 80, SG for port 80. I have to open up HTTP connections. On my app servers, I need to potentially SSH into those. So I need another security group rule to open up port 22. And I'm using the default ports. You can modify that. And I'm going to need a floating IP. So in the demo, we'll see the adding the floating IP to an instance and enabling or opening port 22 and then SSHing into our instance. Okay. This, while the discussion takes a while, once you automate it, it's easy at that point. Okay. Use heat. Take our class. Take my class. The other thing is, and on the right, you see towards the bottom, you can also containerize your application, your database software. So you can add all of that in. Maybe you start off using VMs, and now a couple of months later, I think I want to migrate that to containers. I can just make a duplicate of that heat template and use different resources to containerize my applications. Do I install on bare metal? Do I install on VMs and then run the containers, et cetera, et cetera, et cetera? Okay, so you've got a lot of flexibility for that. Demo. So we're going to demo, and I'm going to use the UI, the dashboard UI. We'll look at the networking setup briefly. Then we'll create a new project, call it webinar. I'll assign users to the project with varying roles. Then, as a user in the project, I'll import an image to the client's repository. When I do that, I also want to define metadata on the image. The image can only be used with a quick emulator or KMU hypervisor. Okay, so if I want to deploy an instance, and I use this image, what that will do is that will ignore all other compute nodes that are running non-KMU, VMware, for example. Okay, we'll create a security group so we can SSH to the instance. We'll look at quotas throughout the demo. And then once the instance is created, we'll connect through the VNC console in the UI, and then create a volume and attach it, allocate the floating IP to the instance, and we'll wrap up with SSHing to the instance. Got a lot to go through. So I'm going to switch screen shares. So I have to stop that one and come back and now share my UI tab. So now you should see the dashboard login screen. While I'm typing the user in, I need to log in as a user with admin privileges, the admin role, so I can do all of the project management and creating users and such. One thing I will mention is you see the Mirantis logo on the screen, and you'll see it on the next screen. So you see the Mirantis logo. The way OpenStack is structured is that's nothing more than like a PNG or JPEG file that you can put your own company logo and use your own company logo instead of the Mirantis. By default, that would show the OpenStack logo. So we've already customized it for our environment. Okay, so I'll mention that. Admin user, admin privileges. Let's review the networking real quick. I'm going to go to the network topology. You have two flavors. You have one that looks like this. I call this the traditional or the old topology. I prefer, for a simple case, the new topology. Whoops. So we've got, in our environment, we've got two networks, public, private, and it's slowly scrolling off the screen on me. You do things live, that happens. Got a public network, private network. Private's where we will launch our instances, and they'll have a 10 dot address. And we've got one router connecting them. So for example, when I SSH to my instance, I will get an address on the public network, our 172 address, and I'll SSH to that 172. That will go through the router and get NATed to the 10.0 address. And that's the default reference implementation for the networking. Again, you may have a vendor that you like, and they may implement it differently. So you have that capability. Okay, quick review of the network then. Now let's create that webinar project. So I have the identity tab, click projects. I want to create a project called webinar. Okay, these are all my projects so far. Create and name. There's webinar. Okay. I have choice here. I could add members if I want, but I haven't created the members for this project. So I'm going to do that in the next step. Right now, I'm just creating the project. Click create, and there it is. Okay. Now let's create two users. We're going to add them to that project. I'm going to call them student 1 and student 2. So username, student 1, and slide the screen up. Password, confirm the password. Now for users, this is an option. What project do you want there as their primary project? That is important when you're using the UI when you log in. So I want them to be a member of the webinar project with the role of member. Out of the box, you've got a couple of roles. Member can do almost everything like deploying instances. The admin role is required for some specific functions, as well as creating projects and users and other roles and such. So that's my user, student 1. When I log into the UI, I will log in for the webinar project. Think about your work. You are probably a member of multiple teams with multiple roles. So you can set that here for each user. So we've got student 1. I'm going to very quickly create student 2. Same thing. And make them a member of the webinar project. Okay, so we've got our two users created. They are members of the project. So if I click the Projects tab and click Manage Members for the webinar project, you'll see those users added by default because I specified that primary project. The other thing I highly recommend is you have a admin for the project, so someone with a team leader type role with the admin role. Okay, and you can create additional roles like team lead. You'll have to update policy files for that as well. And if you need to know that, we got that in our class. The other thing I recommend is also having the admin user, the admin user with the admin role. So in this environment, admin is the cloud administrator, and I usually include them in each project as well. So we've got 4 users in the project now. Okay, I'm going to log out. Now I'm going to log in as student 1. Remember, I have the member role. So everything I do here, by default, any user with the member role can do. You notice project webinar. If I had multiple projects, they'd be in the list, but because I set primary project, That's the project I'm using when I log in. The other thing you notice on this overview tab, quotas. I have quota for 10 instances, 20 virtual CPUs, 10 routers, 10 volumes. Those are defined at the domain level. So every project inherits those quotas. I can change it. I can change the quotas for the domain level. I have to have admin role for that. Or I could change quotas for a specific project. Right now, we're just going to run with the default quotas. Okay, so this is what you get out of the box. And again, in most shops, 10 instances. No, you're going to need a lot more. But this project may only need 2. So I can set that quota for the project and make that lower. Okay. First step to deploy an instance. So I'm under the project compute tab. I need an image. Click images. I've got a couple out here, but I've got a request from the webinar team for a specific image. So I want to create an image, call it webinar image. And then I could either choose file if I want to upload the file from my local machine, or URL. URL allows me to, for example, import that image from a URL, from a location. So 127.0.0.1, that's the loopback address of the machine where my OpenStack's running. Port 8090, glance, the image service is being serviced by Apache server. So the way you read this URL is that port on that machine equates to a specific folder on the machine. And we don't have time, but that would be in the command line, there's an images folder, and that's where my disk file, the Ceros 51, et cetera, .img file exists. So I downloaded it to the machine before the demo. All right. I could see all of that Apache information by going in and looking at the way Apache is configured and the sites available and so on. Okay. But again, interest of time. The other thing I could do is I can specify an external URL. So let me delete that and come back in here. So for example, if I chose the URL here, edu.mirantis.com, I would download that image directly from the edu.mirantis.com server. So I can go externally to servers as well as within my environment. So I'm going to keep it. I want to download that image from this machine. Format QCOW2 for any image dealing with the Quick Emulator or KVM. I have other options here that I just don't have time to go through. But the one thing is I want to make it a private image because the webinar team is the only team that asked me for that. That means no other projects can use that image. And you can see real quick, there's the image that got created. Okay, so we've created the image. Actually, I did not add the metadata to the image. So now let me update the metadata. Okay, you can do it when you create the image or you can do it afterwards. So I don't really care about that. What I want to add in is my hypervisor type. I mentioned earlier that I wanted to make this image available only for the Quick Emulator. That says that any other hypervisor in the list, this image will be ignored for those hypervisors. So, all right. When I create the image, I can do it, but if I want to update it afterwards, I have to have admin access. See, I deviated from my script. Forgive me for that, but I'm going to go ahead and continue on. I'm not going to worry about that. Again, in the interest of time. So I want to deploy an instance using that image. I'm almost there on setting everything up. What I need to open up port 22 so I can SSH. That means I have to deal with security groups and security group rules. Each project has a default security group. I highly recommend create a new one. Okay, why? Well, you may get a fix that changes that default security group, and all of a sudden you've lost your rules. Keep it separate. So egress IPv4 or IPv6, the instance can talk outbound. We're talking packets at this point and packet filtering. There are no ingress or inbound rules, so I can't talk to this instance. If I want to SSH, it's as easy as selecting SSH and clicking add. That will allow me now to allow packets to flow on port 22 to that instance. And I can add others in, such as I want to be able to ping that instance. I want to be able to HTTP to that instance, et cetera, et cetera. Okay, so I'm going to keep it simple. Okay, so we've got a security group. Webinar SG is the name. We've got our image, our Ceros 5.1 image. So let's now launch an instance, the Instances panel. Click Launch Instance, and you can see a series of tabs. This is where I say this is more of an admin interface. There's a lot of decisions to make, and probably not one that you want every user to go through. I see on the right my quotas. 10 max. If I deploy this instance, I'm going to have 10 or 10%. Suppose I want to deploy 11. I set the count field to 11, and right away I'll see I can't do that. So I can see the limits of that instantly. Next screen. What image do I want to use? Well, we uploaded that webinar image. It was our Ceros 5.1. So I just click and upload it or choose it. The other thing I want here is I do not want to create a volume with that image. So I want to say no. Okay. Next screen, how big do I want it? And I've got a series of flavors. I'm just going to pick tiny, a small flavor. Next, what network? We only have one network, so that is automatically selected for us. If we had more than one network, then we would have to select it down here. Okay. Security groups. You always have the default one. I need to add that webinar security group to open up port 22. So I add that to the list. Okay. Click Launch Instance. And that'll take a second to go through. Okay, and in the interest of time, looking at time, we're running out of time. So I've got my instance deployed. I'm going to skip volumes, etc. I'm going to skip using the VNC console. If I want to use the VNC console, I click the link, and then I click the console tab. Okay, what I am going to do now is to show you how to connect into the instance. I'm going to create a floating IP. So I need something on my public network. Click Allocate IP to Project. Take it from the public network. That's the only network I have defined externally. That's giving me a 172.24.146 IP address. Okay, so now I'm almost there. I need to associate that address with my instance. And now I can see that address is associated with that instance. So if I've deployed the instance, I've opened up port 22, and I've got a public-facing 172 address, so I can SSH into that instance using the 172 address. So let me temporarily stop the screen share, and now come back, and at this point, I'm going to have to share the screen to get to my putty session. Okay, so I want to SSH into that instance. And the address was 146. So yes, go ahead and continue. Password for the user. Whoever set these Ceros images up like the Chicago Cubs. Go, Cubs, go. And now I'm in the instance. For example, hostname, webinar VM, IPA. If you look at the Ethernet 0 adapter, 10.0.0.21, that's the instance IP. So real quick, I know I'm bouncing around and going real quick. That's the end of the demo. What I do want to come back to is the presentation. And I've got about 5 minutes to wrap all this up. So let's Chrome tab. All right. So we've done the demo, and I've got a couple of minutes to talk about the COA, Certified OpenStack Administrator exam. For a while in early 2019, it was discontinued, and then later in 2019, about 18 months ago, the OpenStack Foundation, or now the Open Infrastructure Foundation, is in partnership with Mirantis, brought the exam back. So Mirantis administers the exam, runs the exam, the tasks on the exam. Guess who writes the tasks? You're talking to the guy. Okay, so that's another one of my responsibilities. But you have that exam. Okay, why? Well, certifications are key in our industry, and you might be looking for another job even within your company. If you have certification on OpenStack, you'll probably get the interview. Okay, real quick on that one. What is the exam? Vendor neutral, OpenStack. So I mentioned the vendor distributions with extra code, value add code. The exam will test you on just OpenStack. If you're running Mirantis OpenStack for Kubernetes, or Red Hat OpenStack, or EasyStack's OpenStack, you are getting tested on the OpenStack components and tasks, not what the other vendors have added in. So it's consistent across the board. It shows that you know your OpenStack stuff. Okay, you've got OpenStack chops, so to speak. 3 hours, 30 plus tasks, and just recently updated to the USARI release. There's a URL on the slide there. You've got the information on how to sign up. Plus, for those of you that are either attending live or listening to this recorded, through the end of April, you can get $100 off. Use that webinar COA 300 voucher code, and you'll pay $300 instead of $400. Okay, so again, something you get a little benefit by attending the webinar. That's the URL to sign up. It's in different time zones. Typically scheduled, this shows just about once a week, but it might be every other week. Depends on demand. Be careful. You see already some sessions are sold out. When I took this, there were 4 sessions that were available. Might not be the time zone I want. I can always wait for future. We're constantly scheduling them. Okay. Again, the URL is at the bottom of this slide. Key point. You only want to take the exam if you have the experience. What do I mean by that? A guideline, you should be using OpenStack day to day for at least 6 months. Okay, this is not an easy exam, but if you've been using OpenStack, then you meet that criteria, you should be able to take the exam. If you need help, you can always take training that's available. Okay, so from Mirantis Training, I'm going to skip this slide. You've got learning credits, which you can then use for private, public, or on-demand classes or your certification exams. So when you sign up with those credits, you can pay for the classes or the exams using those credits. Private, same content delivered by the Mirantis team. So for OpenStack, 50-50 chance you got me for a class if you choose a private class. Public is delivered by partners. On demand is self-paced, and right now there is no OpenStack self-paced, but we've also got Kubernetes and those classes. So we've got on demand for those. So our training's more than just OpenStack. My world is OpenStack. Real quick on the curriculum, I know we're at the limit. That's why I said questions never get done. Training roadmap. There are 3 classes for OpenStack. An Essentials class, 1 day. Admin and Oppers, 4 days. By the way, before Usari, that used to be 3 days. So I've added a lot more content into that class. Advanced Deployment. Again, that's 2 days. Used to be 1 day. I added in additional content plus a debug section. So we'll help you debug problems. You can see the roadmap. Okay, so after 220, you could take the COA exam, or you could go on and take 320 and then take the COA exam. The minimum requirements would be this 220 class to get you prepared, and that will teach you everything you need to know for the COA exam. The difference is in the class, you get step 1, do this. Step 2, do this. Step 3, do that. In the exam, you'll be given a task. Create the marketing project with these 2 users, with these roles, and by the way, this quota, and that'll all be part of one task. Whereas in the class, it's going to say, okay, create the project, create the users, et cetera, et cetera. It'll take you through step by step. Okay. Slightly different, but if you make it through 220, you've got the skills. Okay. With that, I'm going to leave you with all of the content on the classes. And I'll let you read through the summary again. Yeah, I recognize it was fast-paced. And this is only the basics. And I didn't even get a chance to demo all the basics. If you're interested in any other topics, put that in the as a question, and we can explore that as well. You want to learn more about heat? You want to learn more about Magnum? Whatever it is. You want to learn the next step of the basics part 2? Whatever it is. Okay? We're here to help you guys. And with that, whew, I'll breathe and I'll say thank you. I appreciate you guys attending. I hope you got the information you needed. And again, there's more in those PDFs that you've either been sent or will be sent with the slides and the notes and additional content beyond what I didn't even discuss today. So thank you. And I'll turn it back over to Erica.